Welcome back to my channel Kishore Sir Ki Pathshala. We are doing chapter Work and Energy 9 Cbse Science. So last time we have done potential energy. So today let's see few examples of potential energy. How to solve few examples. Find the energy possessed by an object of mass 10 kilograms when it is at a height of 6 meters above the ground. We have been given acceleration due to gravity, it's 9.8 meter per second square, right? So now let's see how to solve this problem. So we all know that potential energy is nothing but it's mgh. Okay, so it is my m into g into h, that is my potential energy. Now what has been given? Mass has been given. See, mass has been given 10 kilograms, height has been given, right, 6 meters, and g has been, the value of g has been given. So what we need to do, we need to just put the values in this and we'll get the potential energy, that is 588 joule. Okay, I'm sure this is a very simple example. Now let's see another example. An object of mass 12 kilograms, what it's saying, right, is at a certain height above the ground is there. If the potential energy of the object is 480 joule, now the potential energy has been given, right? So potential energy is 480 joule has been given. Find the height at which the object is with respect to the ground. Okay, what we need to find out? We need to find out height. All right. So we know that potential energy is nothing but m into g into h. So potential energy, we have 480 joule. Okay, put all other values. Right, here we have it is given g as 10 meter per second square. Okay, so we get 4 meters as the height. Now let's see, are various energy forms interconvertible? Can we convert these energies? So let's see a few of the examples of the human activity and the gadgets which are involved in converting one energy form into another form. Okay, so gadgets like tube light, we have what it converts. It converts electrical energy into light energy. We have a mixer, what it converts electrical energy into mechanical energy. Okay, we have the sewing machine, so that converts electrical energy into mechanical energy. Gas stove is there, which converts chemical energy into heat energy, right? Likewise, human activities also, you see, the muscular energy is converted into kinetic energy and heat energy. Okay, so eating, the muscular energy converted to mechanical energy and the potential energy. So the energies can be interconvertible from one form to another form. So whenever energy gets transformed, right, then what happens? Whenever the energy gets transformed, the total energy remains unchanged, right? Okay, the energy remains unchanged from one form to another. This is the law of conservation of energy. So it's not lost nor be created. According to this law, energy can only be converted from one form to another. It can neither be created nor destroyed. The total energy before and after the transformation remains the same. The law of conservation of energy is valid in all situations and for all kinds of transformations, right? So now let us see what will happen if an object is falling. Let's see a relationship between a potential energy and a kinetic energy as such. Now we have got an object of mass m, right? We have got an object of mass m which which falls freely from a height h. Okay, we have from height h, that object is falling down. Okay, now at the beginning what you see is that when the object is falling down, the kinetic energy will be 0. Okay, because velocity is 0, right? The total energy of the object will be what? In that case, it will be, suppose that is my potential energy plus kinetic energy, right? So kinetic energy is 0. In that case, it will be my what? It's m into g into h. Okay. As it falls, the potential energy will slowly get converted into kinetic energy. Why? Because the velocity is increasing. Now the kinetic energy is nothing but it is half mv square. Now as the fall of the object continues, it is going down and down and down. When the object reaches the ground, what happens? That time the value of h, it becomes 0. Okay, therefore kinetic energy at that time will be the highest and the potential energy will be the least. Right, it will be 0. Okay, but the sum of the potential energy and the kinetic energy of the object would be the same at all the points. Right, okay, at all the points the sum is the same. That we need to remember. In the absence of air resistance, when an object falls freely, when the object is falling freely, that time what will happen is potential energy decreases while its kinetic energy increases. We have seen the object was falling down, the potential energy it was decreasing and the kinetic energy in that case was increasing. Okay, it's this transformation between the gravitational potential energy and the kinetic energy that keeps the total mechanical energy of the system constant. Okay, so the total mechanical energy of the system at that point is constant. Now let's see a concept called as power. Okay, so in our day-to-day life, we come across this word power, right? That person is so powerful. Okay, then compared to the other, that vehicle is so powerful that compared to other, a stronger person may do certain work in relatively less time. A more powerful vehicle covers more distance in shorter period of time. The power measures the speed of the work done. That is how fast or the slow the work is done. So we can define power as the rate of doing work or the rate of transfer of energy. So we can say power is nothing but it is my work upon time. That is my power. Okay. So now let's see the unit of power. The unit of power is watt. The unit of power is watt, having the symbol as W. Okay, so 1 watt is the rate of an agent which does the work at the rate of 1 joule per second. Okay, how much work is done at the rate of 1 joule per second. So we can also say that power is 1 watt when the rate of consumption of energy is how much? Is 1 joule per second. So 1 watt is nothing but it is 1 joule per second. So we express larger rates of energy transfer in kilowatts. 1 kilowatt is 1000 watt. Right? 1 kilowatt is 1000 watt. Girl of weight 400 Newton climbs a rope through a height of 8 meters. She takes 20 seconds to complete this task. What is the power expended by her? Okay, so we know that weight of the girl has been given, which is how much? Which is 400 Newton has been given. Right. So 400 Newton means what? That is the force which has been applied. So that is nothing but my m into g. So displacement is given as 8 meters. Time taken is 20 seconds. So we know that power is nothing but work done upon time. So that is nothing but m into g into h upon time. Right. So m into g, the value has been given as 400 Newton into 8 meters upon 20 seconds. So the answer what we get is as 160 watt. Let us see another example. A boy of mass 50 kilograms runs up a staircase of 45 steps in 9 seconds. If the height of each step is 15 centimeter, find the power. Okay. G, the value has been given as 10 meter per second square. Right. So now what we need to do here, we have got the m in mg, that is the force, right? So that is my 50 kilograms into g. Okay, 50 kilograms into G, what we get the value of N, right? So height of the staircase is nothing but H is equals to 45 into 15 upon 100 meters, right? So that we get it as 6.75 meters. So time taken to climb is nothing but it was 9 seconds per step, right? So power, we know that is work done upon time taken. So time taken is 9 seconds, we write down here. Okay, the we have this force, right? We have this M into this G, that value we put in here. Okay, height is nothing but 6.75 meters. Height of the staircase, what we have seen, right, is nothing but, okay, so the power we get it as 375 watt. I'm sure you have understood this chapter, work and energy. Thank you for watching my channel Kishore Sir Ki Pathshala. Please like, share and subscribe for more informative videos.